Okay, so I want to talk briefly about one-sided and two-sided limits. I noticed on your quiz that a lot of you had trouble with this. So the idea is pretty simple. One-sided means you're approaching a certain x value from one side, the left side or the right side, but not both sides. Two-sided means, of course, you're approaching from both the left and the right. So let's talk about what that means. Okay, normally when I teach this, I use a Nerf gun, but I don't have a Nerf gun, so we'll just have to go with my finger. So basically the idea of a limit is this. The idea of a limit is if I were to shoot a Nerf gun at something, what does it look like it's going to hit? It doesn't matter if it hits it or not. I don't even care if it misfires, and instead of hitting what it looks like it's pointed at, if it hits something over here. The limit only cares about what it looks like it's going to hit, not whether or not I ever pull the trigger and hit anything, not whether the gun misfires and hits here or even blows back and hits me here. The limit only looks like what it looks like it's going to hit, right? That's the idea of the limit. What does it look like it's pointed at? Not what it actually hits, not whether or not it hits anything at all. What does it look like it's going to hit? So notation-wise, what some of you have been having trouble with is the plus and the minus up in the power position. Now these have nothing whatsoever to do with the sign of the number that you're approaching. In both cases, x is approaching a positive 2. So positive 2 would be right here on the positive x-axis. So in both cases, the x value is getting very close to 2. The negative and the positive in the power position just tell you from which side of the 2 it's coming from. So if you have the negative in the power position, this means the left. Why? Because the left side of the number line is the negative numbers. And if you had a plus, that would be approaching from the right, because the right side is where the positive numbers are. Now, the weird thing is that if you're approaching from the left, you're actually moving to the right. So let's talk about how to figure this out. The easiest way to do it is to note first that this says I'm approaching from the negative side. So go ahead and put your finger or your hand over here on the negative side of the axis. Now find your graph over here. Well, it's way up here. So if I'm approaching from the left, I put my hand on the far left side of the graph and I start moving it towards 2. And this 2 ignores that. It just told me which side to put my finger on the graph. So I'm putting my finger on the graph of f on the far left side, and I'm going to come until I get close to x equals 2. So I'm approaching, coming near, coming near, coming near. I'm not to 2 yet, not to 2 yet, not to 2 yet. No. Okay. I'm not at 2, but it sure looks like when I get to 2, the y value is going to be 4. That's all it means. So that's the answer to the limit. The y value as I approach 2, coming from the far left along the curve, tracing the curve, trace, it looks like it's going to hit 4. And it does hit 4 because it's a solid ball. Now what about approaching from the right? Well, it's the same thing, only this time we're going to approach the same value, x equal to 2, positive 2. If it were negative 2, it would have a negative out in front, not behind in the power position. So I'm going to approach 2, but I'm going to put my finger on the far right side of the graph. So I find my graph, which is the parabola here. I find the right side of it, and I'm going to move my finger along the curve until I get close to x equals 2. Now remember, x is 2 everywhere along this vertical line. So I'm coming down the graph, down the graph, down the graph. It looks like when I get to x equal 2, it's going to hit the y value, which is right over here, at 4. So again, what we're doing is we're looking as I approach, this is x equals 2, and then what's the y value? Y equals 4. Now, once I know what the one-sided limits are, I can ask myself, what's the two-sided limit? A two-sided limit takes both of these into account. And yes, this LIM is, it's more of a squiggle, but it's limit. So now I'm going to have x approaching 2. you'll notice that the two-sided limit does not have any sign in the power position, not a plus, not a minus. When there's no plus or minus there, it is automatically the two-sided limit. So how am I going to figure out what the two-sided limit is? Well, the two-sided limit is actually really easy once you know the two one-sided limits. If you're going to have a two-sided limit, it means that the limit from the left and the limit from the right agree. They both are pointing to the same thing, which means if I'm moving both fingers at the same time, two-sided, does it look like my fingers touch when they get to the X value I'm getting close to? And the answer is yes, they touch at 4 because both one-sided limits are 4. Therefore, the two-sided limit is 4. Now, what if we had instead of a solid ball there, what if we had a great big hole? It doesn't matter. Again, the limit is sort of like a Nerf gun. Nobody cares if the gun fires at all. The gun doesn't have to fire. The gun could fire and hit something it's not pointed at. It doesn't matter. It's what does it look like it's going to hit. The limit means you never really get to 2, so you never really get to 4, but you get really, really close to 2, so you get really, really close to 4. That's it. So let's take a look at another one. Okay, this is a different kind of graph. So now the question is, we'll call this one G, just to distinguish it from the one I just did before. So if this is G of X, and this vertical line here is X equal 1, or negative 1 rather, sorry about that, and this Y value here looks like Y equal 2. The question is, let's look at some different limits. So let's suppose I ask you, what's the limit as X gets close to, note this is not an equal, so I never actually get there, I just get incredibly close. This is sort of like your guardrail on a road. You can get really close, but you really don't want to hit it, right? Okay, so we're going to get really, really close on the graph of G of X to X equal negative 1. Now, if I don't put a sign in the power position, it's the two-sided limit, but I am going to put a sign in the power position. Oops, that didn't show up too well. So we'll turn it into a plus so it shows up a little better. This says X gets close to negative 1 from the right side, from the positive side. So again, how are you going to find that? You're going to go to the vertical line, X equal negative 1. You're going to try to come close to this vertical line, but you're going to put your finger on the right side of the graph of G of X, all the way out here. Now you're going to get close to this vertical line, so I'm coming close, 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 close. What's happening to my finger? It's going up forever, which means that the limit as X approaches negative 1 from the right, that's what the plus means, it's going off to positive infinity, all right? Now, what about if I'm approaching from the left? Again, these two negatives have nothing to do with each other. They cannot possibly cancel. This means X is getting incredibly close to negative 1, though never quite getting there. That means it's approaching from the left side. So I'm coming close to the vertical line at X equal negative 1, but I'm going to put my finger out here, way out here, on the left side of the graph. Approach, 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 get closer, 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 closer. Where is my finger going? It's going to go all the way down to negative infinity. Now, what about the two-sided limit? So this would be the limit as X approaches negative 1 of G of X. Notice that there is no indication as to whether to approach from the right or the left, so it has to be the same approaching from both directions. So if I put my fingers on the far right and far left of the graph, and I trace them at the same time, this is very hard, and I try to get close to are my fingers coming together? My fingers are not coming together. They are not coming together. They are not getting close to each other because this goes to positive infinity and that goes to negative infinity. They don't agree where to go. So in this case, the limit does not exist, or D and E, does not exist. Okay, let's take a look at this example. This is a really complicated one, and I think if you can master this one, you can do any of them. So basically what I have here is a very complicated graph. It's got holes in it. It's got displaced points. These are points that aren't where they should be, okay, in order for it to be continuous. Remember, continuous means you can draw it without having to pick up your pencil, right? You have to jump over that hole, right? And you have to jump over that jump. So this is a displaced point. If it were right there, it would be continuous. This is a jump. There's no way to fix this. You can't possibly make this continuous, right? Because the graph jumps from here up to here. This is also a jump, but unlike this one, where it does have a value at that point, this doesn't have a value at either of the points here at x equals 12. Okay, so first we're going to take the limits as x approaches -5. So as x approaches -5 from the right, okay, so if I were going to come to the far right, I'd come this way, then I'd jump down here, and I'd come like this, and I'm approaching from the right side of -5. And when I'm getting really, really close to -5, it sure looks like it's going to hit the y value of, let's give it some values here, 1, 2, 3, 4. That looks like the y value of 5. Well, then it looks like as I approach -5 from the right that it hits 5. Okay, then the limit from the right is 5. What about the limit as x approaches -5? And again, the vertical line where x equals -5 is right here, then, but approaching from the left. So I go to the far left side of my graph, and I come closer and closer and closer. I'm getting close to this vertical line where x equals -5, and it looks like the y value would be 5. Okay, so again, the limit is the y value. What x approaches is down here. Now, how can I get the two-sided limit? The two-sided limit as x approaches -5 with no indication as to direction in the power position is determined by the two one-sided limits. Do they agree? They do agree. They both say 5. If I'm approaching from the left and from the right at the same time, do my fingers not look like they're going to hit each other? I know there's a hole there, but it looks like they're going to run into each other, and that's all the limit cares about. It's not what you hit, or if you hit at all, it's what are you aimed at. That's a limit. What are you aimed at? So the two-sided limit is 5. Now let's take a look at the limit as we approach -1, which is here where the displaced point is, or the point out of place. We call it a displaced point. So now I want to take a look at the limit as x approaches -1 from the left of h of x. So approaching from the left, as I get close to this vertical line there at x equals -1, coming close. It looks like it's going to hit the hole. So the question is it the hole or is it this value down here that it really hits? And the answer is the limit doesn't care what you really hit. It's what are you aimed at? And it's aimed at -2. So the limit as I approach -1 from the left side is -2, even though it actually hits -4. So what's the limit as x approaches -1 from the right side? Well, if I come from the right side and I'm approaching again this vertical line here where x equals -1, so I'm coming close, coming close, coming close, coming close, closer, 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 closer. Again, it looks like I hit y equals -2. Don't those two agree? Yes. Whether I'm coming from the left or from the right, as I get close to x equals -1, it looks like my fingers are going to hit each other at -2. So the two-sided limit as x approaches -1 is -2. Now let's look at this jump. This jump is going to be a little different. So we have two jumps left. We have one at 7, x equals 7, and one at x equals 12. One of them at x equals 7 is defined at x equals 7. That's 2. So this ordered pair here is 7, 2. The one at 12, it's not defined at either point. So we have no value for the function at that point. So let me go ahead and get